In this video, we will cover section 6.2 on inconsistent and dependent systems. So when we were solving systems of equations earlier, we ended up every single time getting an ordered pair or an ordered triple. In this section, we're going to look at what happens when there is either no solution or infinite solutions. An inconsistent system is a system that has no solution. A dependent system is a system with infinite solutions. So our first example is a three-variable linear system. 2x minus 4y plus z equals 3, x minus 3y plus z equals 5, 3x minus 7y plus 2z equals 12. So how we've been solving linear systems from section 6.1, we're going to stick with that method and use our graphing calculator and matrices. So our first step would be to create the augmented matrix for this system. So 2, negative 4, 1, 3 in the first row comes from the coefficients of x, y, z and the constant in equation 1. 1, negative 3, 1, 5 from the coefficients of x, y, z and the constant from equation 2. And then our last row, 3, negative 7, 2, and 12 that come from the coefficients of x, y, and z and the constant in the third equation. So we should input this into our graphing calculator. So that's when you hit second and then the x to the negative first key to access the matrix menu. You scroll over to edit and press enter. You indicate that it is a 3-row, 4-column matrix if that's not already set. And then you'll type in these numbers. Once all of those numbers are typed into your boxes on your calculator screen for the matrix, you're going to hit second mode to quit, and that should take you back to the home screen. Then you will go back and hit second x to the negative first to get back to matrix. This time move to the second column that says math and scroll down until you find the command RREF. Once you get to that command, you'll press enter and it should pull up RREF to your home screen. Then you go back into your matrix menu a third time, so second and then x to the negative 1 is your matrix menu. This time just press enter so it pulls up matrix A to your home screen. And press enter again, and this is what you should see. 1, 0, negative 0.5, 0, 0, 1, negative 0.50, and 0, 0, 0, 1. So this is the reduced row echelon form of this system of equations in its augmented matrix. So just like always, we will translate, once we get our RREF form, we're going to translate each row back into equation form. So remember, the first column is for x, the second column is for y, the third column represents z, and then our last column is our constant. So this first equation would read back as x, 1x, there are no y's, minus 0.5z equals 0. So we've written that right here. Our second line, there are no x's, so this would mean 1y minus 0.5z equals 0. That's our second equation. However, our last equation, we see 3 zeros in a row. So there's no x's, there's no y's, and there's no z's. So that would mean 0 equals 1 would be our last line. And 0 obviously is not equal to 1, so this is a false statement, which tells me that this system has no solution. If you have a no solution case, these equations do not matter. You're just done. So you will just say the empty set, no solution, and move on. When we have an infinite solution case, then these equations do matter. But for no solution, that's the end of it. If you were solving this without a matrix algebraically, and you were doing the elimination method, at some point of your solving process, you would get something similar. You would get 0 equals 1 or 2 equals 5 or something like that. The variables would drop out and the two constants would not be the same. So you would stop and say no solution, just like we did here. So let's try another example. X plus y minus 10z equals negative 4. X minus 7z equals negative 5. And 3x plus y minus 36z equals negative 10. So we will do the same thing to set this problem up. 1, 1, negative 10, negative 4. 1, 0, because there are no y's in the middle equation. So we put a 0 in that position. Negative 7, negative 5. 3, 5, negative 36, negative 10. So we input this in the calculator. Once that's put in the calculator, we quit back to the home screen. We pull up the RREF command, go back and pull matrix A into that command and press enter, and this is the matrix that you would get. 1, 0, negative 7, negative 5, 0, 1, negative 3, 1, and 0, 0, 0, 0. So just like before, we will translate these back in equation form. So this top equation would translate back as 1x, no y's, minus 7z equals negative 5, right here. X minus 7z equals negative 5. The second line, there are no x's, so this would mean 1y minus 3z equals 1. So y minus 3z equals 1. And then our bottom row, again, we have the zeros on the left of the first 3 entries and then a 0. So this would mean 0 equals 0. So this bottom line, all the variables dropped out, but that is a true statement. 0 equals 0 all the time. So when that happens, that tells me that we have infinite solutions. However, we are going to take infinite solution problems a little bit further. Instead of just saying that there are infinitely many, we are going to write a formula to show us what they actually look like. So when you get infinite solutions, you're going to come back up here and you're going to take this first equation and you're going to solve it for x. So we're going to rewrite this as x equals, we'll add the 7z to both sides and get 7z minus 5. Then we're going to take the second equation and solve it for y. So right here, if I add the 3z to both sides to get y by itself, I get y equals 3z plus 1. And then 0 equals 0, it's like saying z can be any real number. So z can just be z. And we use itself because that's the variable that these two are defined in terms of. So our x value is 7z minus 5 in the ordered triple. The y coordinate of the ordered triple is 3z plus 1. And z is basically any real number that I want it to be. So this is still saying infinite solutions. It's just saying that if I choose any real number for z, then I can figure out what x and y go with that particular choice using these formulas. So this means z can be any real number, and x and y can be determined based on the value of z, still leading me to infinitely many ordered triples, because I have infinitely many choices for z. In this section, we'll also encounter what we call non-square systems. A non-square system will always have either no solution or infinite solutions. You'll never get just a single ordered triple. A non-square system basically means it's a systems that do not have an equal number of equations and variables. So there might be 2 equations, 3 variables, or something like that. So let's do an example of a non-square. So here we have 3x plus 2y minus z equals 5. X plus 2y minus z equals 1. So this one has 2 equations, but it has 3 variables still. So this is non-square. So we can still use our matrix option to solve. So we're going to start with our first equation, 3, 2, negative 1, 5. And then our second equation, 1, 2, negative 1, 1. So when we put this in our calculator, when you go into your matrix menu and over to edit, you will have to change the size because this is now a 2 by 4. It only has 2 rows, but it has 4 columns. So you'll have to adjust your setting there to be a 2 by 4 instead of a 3 by 4. Then you can type in your numbers like we did before. Again, you're going to have to quit after you do that. Go back into matrix and then over to math to pull up RREF. And then back to matrix and pull up matrix A again. And when you press enter, you will get this result. 1, 0, 0, 2, 0, 1, negative 0.5, negative 0.5. In the infinite solution case, which is what we're going to have here, and we'll get to that part in a minute, MyMathLab will not let you use decimals. So if you have decimals and you need to convert those to fractions, these are, you can convert easily in your head, right? Because it's 0.5, we know that that equals a half, but sometimes they're not. So if you get matrix entries that happen to be decimals and you need them to be converted to fractions, when this happens, you just press the math key, which is right below your green alpha button. So you are not going to go into matrix. Just press math, it's right below the green alpha button, and then press enter twice. And that will convert to a fraction. And when you convert that to a fraction, you should see this result. 1, 0, 0, 2, 0, 1, negative a half, negative a half. So then we can translate back our equations. X, no y's, no z's, equals 2. Second row, no x's. This is the y column, so y minus 1/2 z equals negative 1/2. So our top row is x equals 2, but our second row is y minus 1/2 z equals negative 1/2. We don't have a third row, so this one is like saying that our third row is all zeros. So it's the same as just saying that I can choose any number I want for z. This would have no solution if this bottom row was 0, 0, 0, 1, right? So that still could happen. But when that doesn't happen, then we have infinite solutions. So this second line we can rewrite as y equals 1/2 z minus 1/2. So we have an x value this time. So in our ordered triples, x is always 2. However, this is the value of y, 1/2 z minus 1/2. And since that one is in terms of z, again, we just let z be any real number. So z is itself. And that is the end of section 6.2, and that is all we are going to cover out of chapter 6.